We now discuss the solution of a problem from the section Vector Algebra. The problem is related to coplanar vectors. This question has appeared in the joint entrance examination main held on 28th June 2022 in the first shift. The given question is if vector A is equal to 2i plus j plus 3k, vector B is equal to 3i plus 3j plus k, and vector C is equal to c1i plus c2j plus c3k are coplanar vectors, and A dot C is equal to 5, B is perpendicular to C, then 122 times in brackets C1 plus C2 plus C3 is equal to. We are given three vectors, vector A, vector B, vector C, and it is further given they are coplanar vectors, and it is also given A dot C is 5, B is perpendicular to C, then required to find the value of 122 times in brackets C1 plus C2 plus C3. We now discuss the solution of the problem in detail. We have the vector A given as 2i plus j plus 3k, vector B given as 3i plus 3j plus k, and vector C is equal to c1i plus c2j plus c3k, and where c1, c2, c3 are unknowns for the time being. Agreed. It is given that vector A, B and C are coplanar. Then if they are coplanar, the box product of the three vectors A, B, C is equal to 0. In other words, the scalar triple product of the vectors, three vectors A, B, C is equal to 0. This can be written as the bracket CAB is also equal to 0. Now write down in the determinant form. This will imply the 3 by 3 determinants whose first row is the components of C, C1, C2, C3. So the second row are the components of A, 2, 1, 3, and the third row are the components of B. They are 3, 3, 1. The determinant of that is equal to 0. Expanding this determinant by its first row, we get this one. And we are very familiar with the expansion of the determinants. Agreed. Simplify, we'll get minus 8c1 plus 7c2 plus 3c3 is equal to 0. Let's call this relation as equation 1. Given A dot C is equal to 5. Write down the vector A dot vector C and take the dot product equate to 5. When taking the dot product, it is 2c1 plus c2 plus 3c3 is equal to 5. Agreed. That is the equation 2. And we are further given B is perpendicular to C. When they are perpendicular, the dot product must be equal to 0. This will imply write down the vector B dot, write down the vector C is equal to 0. Take the dot product, then you will get 3c1 plus 3c2 plus c3 is equal to 0. Let's call this as the equation 3. Now we got 3 equations, and in 3 unknowns we got. The unknowns are c1, c2, c3, and solving these 3 equations is not difficult. It's very easy. Any of the methods that we have learned can be used, and use such result, and find out C1, C2, C3 and find the value of 122 times C1 plus C2 plus C3. Agreed. That we will do in the next slide. And we have those three equations, equation 1, equation 2, equation 3. And I prefer to solve these three equations in three unknowns by Cramer's rule. But first of all, let us see what are these. These are non-homogeneous linear equations. It is a system of non-homogeneous linear equations whose matrix equation is this one. That is minus 8, 7, 3, 2, 1, 3, 3, 3, 1. That's the matrix multiplied by the column vector of unknowns C1, C2, C3 is equal to the values, that is the column vector consisting of 0, 5, 0. It is a non-homogeneous system of linear equation. It's of the type AX is equal to B. And we solve this equation because C1, C2, C3 values you have to find, and we solve by Cramer's rule. And we have used the Cramer's rule because the values of C1, C2, C3, 122 times of the sum of C1, C2, C3 we have to find. That means we get the unique solution for C1 and C2, C3. It is then only 120 times can be found out. Agreed. So we prefer to solve the Cramer's rule. So first of all, we find delta. What is delta? Delta is the determinant of the coefficient matrix. Delta is equal to the coefficient matrix is this one, determinant of that. Agreed. And expand by first row. We are very familiar with the determinant expansions. And simplify. 64 plus 49 plus 9, that is 122. Agreed. And we find next delta 1. What is delta 1? Delta 1 is same as delta. The first column is replaced by 0, 5, 0. Replaced by the column vector B, that is 0, 5, 0. Now you expand by first column. By first column, this is 0. And this is which element? Second row, first column. Second row, first column means 2 plus 1, 3. Therefore, it should start with minus 5 times, 5 times the minor, we have to write 7 minus 9. That is equal to 10. And the common mistake the students will do in the expansion of delta 1 is they will write 5 times of that. Then you will get the wrong answer. So delta 2 is equal to, say delta 2 is same as delta with the second column 713 is replaced by 050. 050. Now expand by the second column. And the 5 is, this one is second row, second element. Second row, second element means 2 plus 2, that is 4. 4 means even. Even means plus. Plus 5 times. Minus 8 minus 9, minus 8 minus 9, that is minus 85. Delta 3. And delta 3 is same as delta with the third column replaced by 050. Now replace by third column. Now expand by third column. So 5 is sitting in the second row, third position. Second row, third position means 2 plus 3 is 5. 5 is odd. Therefore, minus, you have to start with minus 5 into minus 24 minus 21, that is 225. We got delta, delta 1, delta 2, delta 3 and use the Cramer's rule. By Cramer's rule, you will get C1 value is equal to delta 1 by delta, that is 10 by 122. C2 value delta 2 by delta. Delta 2 is minus 85 by 122. C3 is delta 3 by delta, that is 225 by 122. Now add C1 plus C2 plus C3 and the denominator is same. Therefore, you will get the same LCM and you will get 10 minus 85 plus 225 by 122. Now cross multiply, you will get to 122 times C1 plus C2 plus C3 is equal to, this is 235 minus 85, that is 150. So 122 times C1 plus C2 plus C3 in brackets is 150. That's what we are required to find, and we got the answer. So the answer to this question is 150. That is the detailed discussion of the solution of the problem related to the coplanar vectors from the vector algebra. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.